Alright, mathematicians, here is a quick video on how to do one of the homework problems. I've copied down here number 23, and I just wanted to send this out for you for some help before I head off to class, and that way you would have it tonight when you check your answers. So for number 23, they say, find the interval of convergence for the geometric series. And I didn't do a precise example like this in class. You can look back in the section for more information, but I wanted to give you some groundwork. We know that a geometric series converges to a over 1 minus r, provided that the absolute value of r is less than 1. And that's really the guiding principle behind all problems like this that can be represented with geometric series. So what I'm going to do is just rewrite this problem so it's a little clearer to see what our common ratio is. So I can use, exponent laws and rewrite this as negative a half times x minus 3, the whole thing to the n power. And then it's clear that this would be a geometric series with a common ratio of whatever inside here. If we had a constant on the outside, that would correspond to our a, but we don't here. So this geometric series converges precisely using this formula. And again, the constant on the outside would just be a 1. So this is going to converge to or equal 1 over 1 minus the entire common ratio. What's the entire common ratio? Well, it's just a whole expression, this negative half x minus 3. That's what the series converges to. But that's actually not what they're asking in this problem. They don't want to say what does it converge to, but rather what is the interval of convergence. So the series converges to this fraction here, this ratio, provided or when the common ratio, the absolute value of the common ratio is less than 1. Okay, as we said over here for our principle, r had to be less than 1. Absolute value of r is less than 1. So this will be converging when this entire expression, negative half, and I'll just distribute it, x plus 3 halves is less than 1. Okay, that's when it converges. So this is a little messy way to leave it. So one way you can clean up the expression algebraically is to realize that absolute value less than 1 is the same thing as saying it lies between negative 1 and 1. And then you can just use good old-fashioned algebra to solve this for x. So I would subtract the 3 halves from both sides. I'll do that over here. I'll go over here. Subtract 3 halves, and we'll have negative 5 halves less than negative half x less than negative half, and then multiply everything by negative 2. Just be careful, you gotta switch the inequalities, multiply everything by negative 2, and we have 5 greater than x greater than 1. So the interval of convergence, I'll rewrite it one more time, would be 1 is less than x is less than 5. That's the interval on which this series converges, and you know you're done when you have x isolated. That's the best way to write the interval of convergence. Okay, so that's just a short video. Hope that helps you out with the homework, and you feel free to email me and ask questions in class tomorrow. Have a good night.